Hello Year 12, here's a quick video on two-tailed tests. When we're looking at a two-tailed test, the only difference to a one-tailed test is the claim that's been made in the alternative hypothesis. We're not sure whether it's going to be less than or greater than. So if a question suggests that on average the chance of us getting a 6 is 1 out of 6, and a particular person is doing a sample of 30 and they know that the dice is biased. However, they don't know whether the dice is biased towards giving 6s or towards not giving 6s. So that's what we're basically trying to test in there. And the most important thing is notation. So our null hypothesis is where probability equals whatever's been the norm. And the alternative hypothesis would be probability is not equal to that. So rather than doing greater than or less than, we don't know where the probability is going to go. The other thing to bear in mind is the significance level. Now, if the significance level is 5%, which is 0.05, then we are looking at either tail of the test and we will split up the significance level. So towards the lower end of the tail and towards the higher end of the tail, we will split the significance level up so it becomes 0.025 on this end and on the top end 0.025 as well. So what you're trying to find is two sets of critical values, really. One will be at the bottom end, which means anything less than that value will lead us to reject the null, and anything higher than this value will lead us to reject the null. Okay, let's have a look at an example question. So, this is an example question. Records show that the proportion of trees in a wood that suffer from a particular leaf disease is 15%. Sam thinks that recent weather conditions might have affected this proportion. Now, the key word here is affected this proportion. Sam doesn't know whether the recent weather conditions have increased the number of trees that suffer from this particular leaf disease or reduced. But Sam thinks there's a difference in this proportion now. She examines a random sample of 20 of the trees. Part A says, using a 10% significance level, find the critical region for a two-tailed test of Sam's theory. The probability of rejection in each tail, that should say Sam there. The probability of rejection in each tail should be as close to 0.05 as possible. Now in this case, as you can see, the significance level has already been split up here. Now, normally we reject the null if the probability of an outcome that we have obtained is less than that significance level. However, in this case, we've been asked that the probability of rejection in each tail should be as close to 0.05 as possible. So we're going to be putting that to test and having a go. The first thing to do in any hypothesis testing is to write down your variable and write down your hypotheses. So if we go here, X is the number of trees that suffer from a particular leaf disease out of 20. The null hypothesis, the probability that we know of the norm is that 15% of the trees have this particular leaf disease. The alternative hypothesis, what Sam's claim, is that the probability is no longer the same, it's different. The distribution has to be stated, which is here. X is distributed according to binomial distribution, with 20 as the number of trees we are looking at and 0.15 as the probability of success, which is the fact that they have a disease. And our significance level is 0.1, which will get split up in 0.05 on either side of the hypothesis test. But look at this diagram here on the side. I've just shown you that if the data goes from 0 to 20, which are the 20 trees, the rejection region where we can reject the null, i.e. how many trees need to be on this end for us to reject and how many trees need to be on this case, which means something like if let's say this is 7, that means out of those 20 trees that we have looked at, 7 or less trees would have had to have the disease for us to accept Sam's claim that the number of trees that get the disease has obviously changed, in this case reduced. If we look here, then this could be, I don't know, 18. That means, again, it's gone worse. That means more trees are getting the disease. So what we're trying to find out is these critical values here. What is x1 and x2? What you've got in the middle there is the acceptance region, which means in this case, we don't have enough evidence for us to reject the null and go with Sam's claim. Okay, so that's what we're trying to find out really. And make sure you always split up the significance values for either end of the two-tailed test. When you're looking at critical values, it's best to have a list mode on your calculator. I've looked at the lower end of the tail first. So I've looked at, I could see that the probability of x is less than or equal to 1 was 0.1755, and that's greater than 0.05. And the probability x is less than or equal to 0 is 0.0387, which is less than 0.05. Now, of course, that is what we would go with, because if you look at the distance as well, remember what the question said, the probability of rejection should be as close to 0.05 as possible. So what I do is I look at the distances between the outcomes, the probability of the outcomes, and the significance level, and I write down the difference between them. And the lower that number, the better it is, because that means it's closer to 0.05. So in this case, we are closer, and it's less than 0.05 as well. So this is the critical value on the lower end. We go to the upper tail, the top end of this distribution. Again, looking at the list mode, here you would need another calculator because we are looking at greater than values. We're saying 6 or more trees would have had to have the disease. Now, our cumulative binomial distribution does not look at greater than, it looks at less than or equal to. So you would need another calculator to do 1 minus the probabilities. Now, when I did probability x is greater than or equal to 6, this is what I get. 1 minus the probability of x is less than or equal to 5, which comes out to 0.0675. And I look at the distance from that to 0.05. Now, this is greater than the significance level. So you normally would go to the next one, which then I did probability x is greater than or equal to 7, which is 1 minus the probability x is less than or equal to 6, which does give me a probability which is less than the significance level. However, the question does state that the probability of rejection should be as close to 0.05. So again, you look at the distances only in these questions where it asks you to. You look at the distance between the probability of the outcome to 0.05, and you pick the one that's got the lowest, the least distance between them, which means closest to that probability. So in this case, we pick this value here, which is probability of x is greater than or equal to 6. And then finally, the critical region is that x is 0 and x is greater than or equal to 6. Putting this in perspective, it means 0 trees would have had to have the disease out of 20 for us to have rejected the null and concluded that the probability in the distribution has changed. The distribution has changed. The number of trees, of course, has changed. Or out of the 20 trees, 6 or more trees would have had to have the disease for us to again reject the null and accept that Sam's claim is indeed true and that the recent weather conditions might have affected the proportion of diseased trees. Okay? If we have a look at part B, it says, find the actual significance level of a test based on your critical region from part A. Now, the actual significance level is found by adding the probabilities under your null hypothesis of the test statistic falling in each part of the critical region, which means in this case, all we have to do is we have to add the probability x is equal to 0 to the probability that x is greater than or equal to 6. This is our actual significance level. So if I add up 0.0388 plus 0.0673, it gives me 0.1061. You could also give this as 10.61%. That's the actual significance level of our test. Part C. Sam finds that 8 of the sample trees have the leaf disease. Comment on this finding. Now, this observed value of 8 falls within our critical region, because our critical region is that the number of trees for us to reject the null and accept the alternative has to be greater than or equal to 6. So the fact that Sam has found that 8 of the sample trees have the disease, we can say the observed value is within the critical region. And that's sort of the first thing you would have to say. The second thing is, going along with our conclusion, there is enough evidence at the 10% level of significance to reject the null and to support Sam's theory that there actually has indeed been a change in the proportion of trees affected from this leaf disease. Okay, I hope this helps. Take care and stay safe.